Signore e signori, buongiorno. Questo è il nostro dottore Markus Wilkens, che lavora nel nostro reparto di sviluppo e lui ci guida oggi attraverso questa presentazione. Mi chiamo Daniel Corte e io sono responsabile delle vendite presso l'azienda Hengst. Hengst è una impresa a gestione familiare fondata nel 1958 con un giro d'affari di circa 500 milioni di euro. Con le nostre sedi, 21 sedi, siamo quasi in tutto il mondo. La nostra sede principale è a Münster, Westfalia, Germania, circa 2 ore da nord da Colonia. In totale siamo circa 3.000 impiegati. Normalmente siamo ben conosciuti dall'industria automobilistica, ma vi offriamo anche soluzioni di filtraggio elettrodomestici oppure per la pulizia professionale. Se volete scoprire più su di noi, siete benvenuti al nostro stand nel padiglione 4 F1 e adesso divertitevi con Markus. Grazie.
Thank you very much, Daniel, for this kind introduction, and also from my side, welcome to my talk. The title of the talk would be Standard and Regulation for Professional Cleaning Applications. So, professional cleaning is a field which is more or less a field which is as much as possible full of standards and regulations and so on. And let's say if we start with this point, every region has a different standard, then we would see, if I put all standards on this map, you will see this is just a small amount of the standards. You wouldn't see anything out of this card if I put all standards on this small slide. Due to this, I just want to focus on some, in our optical view, main standards which are necessary for filtration, especially, and filtration in vacuum cleaning. If we start here in Europe first, where I really would start my talk with, we have focusing here on more or less three main standards, which is the EN 60335, which is in most cases necessary for construction work. If you use a vacuum cleaner construction work, you have the EN 1822, or new standard since 2019 is the ISO 29463, and just as a special or an example that there are much of different standards, a standard AFS for Sweden, which is also for more or less construction work or hills. And furthermore, I would go to some standards in the US, so OSHA regulation, ISP and ASTM, which is here again more or less for construction work. And here, this is a standard really which is used for, let's say, professional cleaning, hotels, mobiles, and so on. And I just show some slides here, for example, Australia, which is more or less similar to US, or a lot of Chinese standards are also available. I think these are 5 pages, just standards for vacuum cleaners. They are more or less focusing a lot on European. Other countries like Austria and so on are focusing a little bit more than on the US market. So, as I said, as a starting point, I would start with the European 60335 standard, where we have 3 different kind of dust classes or filter efficiency values. This is a little bit a more or less old-fashioned table for this kind of standard, but I think it shows really good and gives an overview about the standards, because you can see here that we have limited values of maximum penetration or opposite the filtration efficiency which is needed. Where you can see here, you have a maximum allowed penetration of 1%, which means 99% of efficiency. And it goes down to the highest class for, let's say, dangerous dust systems, where it's just allowed to have a penetration of 0.005, which is a really high efficiency which is needed. Also interesting is here that we have different kind of dust systems for the test, and also different kind of certifications which are necessary. So for class L and M, for example, it's just necessary for us as supplier of filter elements to certify just the flat sheet material, so there's no focus on the processing of the filter bag itself. So there's no focus on maybe a destroying treating process or whatever. And if you go to an H class, there's a bigger focus on the complete filter element, and due to this we have to test the flat sheet and the filter element, and of course in all cases you have to test the complete vacuum cleaner at the end. And I think you will also see sometimes it's possible to get an M class of a vacuum cleaner just with an A class filter element. And also it's possible to just get an M class for the vacuum cleaner with an H class filter element. It depends always on the combination of vacuum cleaner and filter, and of course the construction of the vacuum cleaner itself. Just as a short overview to know which kind of application is used, or for which kind of application, which kind of dust class is necessary. This is more or less an overview which is for Germany at the end, but I think also it's usable for every country in Europe. So for L class, you have just to use an L class filter element, for example, for model or dental technology, clay, ceramic products, and so on. So really simple, basic dust. Then you can use an L class filter element, which is, from our point of view, more or less really old-fashioned, because I think we just have one or two L class elements at the moment, because of getting more and more regulations, and due to this, in most cases, we have to use an M class as a standard at the moment, especially if you take a look here. Even if you work with wood, or wood which is preservative or something, you always have to use an M class filter or an M class machine, which I think is not always done, but it should be done. And if you go, of course, to dangerous dust system like asbestos, or if you have formaldehyd in wood or whatever, then it's necessary to use an H-class filter element. And as I said, you really have to certify the complete machine and also the filter element itself. Just to have an idea of how the test is done, for L and M class it's more or less the same test equipment. As I said, you use flat sheets for this test. The test is done with 6 different flat sheets, which we have to provide to the test institute. And we use, or they use, a kind of quartz dust system, and with dust concentration of around 200 milligrams per cubic meter. The interesting point here for this kind of test is that we and our customer define more or less the inflow velocity or the filter area load, which means, or let's say there's just a standard value of 200 cubic meters per square meter an hour, which is more or less a standard for most of the certified filter materials. But if you take a real look into the application for vacuum cleaners, you will see that you have, in most cases, a filtration load in the region up to 400 cubic meters per square meter. And due to this, we do our N-class flat sheets always a certification from 200 up to 400 cubic meters per square meters to be really safe, that there will be no mistake or error due to the certification. Maybe one interesting point in this, or let's say maybe not so good effect of this test, is that the test is done for 1 hour, and the first measurement point is after 5 minutes. This means if you have a really high inflow velocity with a dust concentration which is dependent on the volume flow you have, as much higher the inflow velocity, as much higher as the dust concentration, and first point after 5 minutes, so you already have a kind of cake formation. So If you just, for example, get an M certificate, which is at 400 cubic meters per square meters, mostly the reason is that at 200 cubic meters per square meter, the material fails the test, because there was no dust cake helping due to the efficiency. As I said, for H class, you have to test the complete filter element in this kind of test rig, and we doesn't use a dust system. It's a test aerosol like for EN 1822, but also with different kind of concentration. And what is maybe interesting, it's the multidisperse aerosol, which means 90% of the particles are below 1 micrometer. So nothing which is in the region of an HEPA filter element, which I will explain a little bit later, but just as an indication, if you want to get an H-class filter element, you need a minimum an E12 EN 1822 filter element. At the end, this test is more or less similar, because you always detect the concentration before and after the filter element, and detect in this way the penetration or efficiency. So maybe interesting for you as a trophy for let's say, if you produce a vacuum cleaner, it's maybe interesting for you to know which kind of filter material can be used for which kind of filter class, which means for the lowest filter class, as I said, you can use a simple basic cellulose material or even a polyester material, or of course a blend material, which is at the end really cost a price sensitive market, and you have at the end, just as an indication, maybe you know air permeability, so more or less a kind of differential pressure of the flat sheet material. Where you see, okay, if you are above 200 liters per second per square meter at 2 millibar, then you will have a material which is in the region of an L-class element, which is for both, also for cellulose and polyester material, more or less the same. For polyester material, you can always see, if you get a material which is in the region of 100 grams per square meters in grammage or weight of the material, it will always be just an L-class. If you want to have an M-class with just a pure polyester material, it's always you always have to go to a higher grammage, let's say a minimum, for example, 250 grams per square meter. But at the end, it's always also possible to get with a cellulose material or polyester material and M-class filter material. As I said, just material, not filter element, because it's not tested. But the air permeability range will be below 200 liters per second. But if you have a problem, or the problem that you have to take care of differential pressure or volume flow, which is possible in the vacuum cleaner, then you have to switch to a kind of coating of the material. You have two possibilities, a Ptfe coating or a nanofiber coating. The Ptfe coating is really stable, it's washable, but has this is more or less the benefits, but you have the problem, your differential pressure will increase in all cases, because it's a tight structure with a high resistance to airflow. But if you want to have a low differential pressure, then you go to a nanofiber material, because it doesn't affect at the end the differential pressure, and you can use let's say in this case, for example, a 180 gram per square meter polyester material, which is just an L-class, high air permeability, and then you make a coating with a nanofiber, and you will get an M-class, and you will have the benefit at the end that this kind of material gives you a much better cleaning efficiency or back cleaning efficiency. Regeneration is much easier, because here it's really a surface filtration, and here it's let's say more or less a surface filtration. It's also kind of dust filtration possible for this kind of materials. If we go to H-class elements, then we have to say the state of the art is at the moment just glass fiber material, maybe coated with polyester material to crack it a little bit, or sometimes you have a cellulose material with a glass fiber material on it. but you always have the problem that this kind of elements are not back cleanable. It's not possible to clean really a glass material because it's a dust filtration material, which is, let's say, at the end, normally used at the end of lifetime filter for exhaust air or whatever. But due to some new market trends and some really new developments, it's also possible now to get Ptfe coated H-class filter elements, which is already in series production at our facility. It's really complicated due to the fact that I said it's no problem to get a Ptfe material, which is at a flat sheet at H-class, but after production, so pleating, if you make some knobs for stabilization inside and so on, you always destroy the Ptfe membrane. You will always see some holes inside, and then you will have a reduction in efficiency. And we found a way to produce such kind of material without any damages, and also some other modification of the material, which lead to a really good back cleaning efficiency, and also the possibility to get an H-class element without glass fiber. Glass fiber is a good point at this time, because if we go to EN 1822, we normally always use, or the standard was in the last years, always with a glass material, because we have really high requirements due to efficiency. At the end, the EN 1822 is classified in 5 parts. So the classification part, the test equipment which is necessary, the test method for flat sheets, a leakage test which is necessary for higher filtration classes, and the efficiency of the filter element itself. And as you can see here, we have more or less 3 classes of filter efficiencies. This means IPA, EPA, and ULPA filter class. And you can see here the different efficiency values which are needed. For example, 85% for an E10, and for an H30 you have 99.95%. But the question is always at which particle size. And here you have to use the MPPS, which means most penetrating particle size. So this means the lowest efficiency you can get is the efficiency you have to take care for this kind of filter element. Let's say normally the MPPS is in the region of 0.15 micrometers. And up to the trend of Ptfe materials, we often have an MPPS of 0.04 or 5 micrometers, so really small particles, and you have to reach this really high efficiency. What is interesting here is that you have IPA classes, where you just have to validate the complete efficiency of the filter element. And for H classes and also ULPA classes, you have to detect a local value, which means that you will scan the complete filter element, as will be shown on the next slide. And it is not allowed that any point on the filter element has a lower efficiency than 99.75, for example, for an H30 filter element. Up to now, EN 1822 is not valid anymore, and we have to use a new standard, a new ISO standard. And to make it a little bit more complex, we changed a little bit the filtration classes, which means, for example, an E10 is now get more or less lost, and every filtration class we had before is now more or less divided into 2 new filtration classes. From my point of view, it's really okay for an E11 material, because we have a huge range between E11 and E12, which means 95% to 99.5%. And now it's divided into until 95 and 99%. But if you come to higher classes, it's really small amounts which are changed. And due to this, most common is at the moment just EN 1822, but at the end we have to switch to the ISO standard in future, which means If you go to a HEPA filter, then it will be a minimum ISO 3.5 and an H for HEPA. As I said, it is necessary for a HEPA filter to also detect local errors in the filter element. This is just a scheme of our testing which we are currently using. Where you can see here we have particle counter. This is the filter element, and here you have the ventilation system and the aerosol generator, and again a particle counter, and you will, as simple as possible, detect the particles on the raw gas side and also on the clean gas side. But you will not detect everything of the filter element at once. You will take just small spots as an isokinetic test to get really the local efficiency, because it's possible, or let's say, you can have a filter element which is at this point 99.9995 and at another point 80%. And the mean value will be 99.95, but you will have a big leakage. So due to this, for HEPA and ULPA, you always have to make a kind of a leakage test. And to be a little bit more complicated, for HEPA and ULPA, every filter element which you produce has to be tested 100% of leakages, which means you do not have to test really the complete filter element with all different points. It's just more or less a leakage test, which can be done by a kind of an oil line test, which an optical impressionist, or you also can make a more simple test with a multidisperse aerosol and test the complete efficiency, the integral efficiency of the element, but it has to be done on every part for 100%. For example, here's a test result which also shows a little bit the MPPS. Here we tested one filter element at two different volume flow, which also indicates the efficiency, of course, is dependent on the volume flow. So you can switch, let's say, a filter element between HEPA and HEPA if you just change the volume flow of the vacuum cleaner. And MPPS means here really this minimum in the graph. So you have different particle sizes here, and the minimum is the MPPS, and here you have to reach your filtration class, which means in this case 99.9895. So it's an H13 filter element at, of course, different volume flows. But as you can see, if you go to higher volume flows, also the efficiency will decrease, and you will come at the end to a meter, for example. And here, this is always an interesting curve because it shows the length and the width of the element and the detected particles on the different areas, where you can see here is a really good filter element because you have no peaks in any region that you have any kind of leakages here. Okay, no good. Okay, as I said, as a more or less a special standard for you is, for example, a Swedish standard, or it's more or less an example for all Scandinavian standards, because they switched a little bit around between IFA class H and a HEPA class for especially construction work filter elements. There are different standards in this region, and depending on where you look at the end, you will find sometimes that it has to be a HEPA. So a European HEPA filter element. Also, you can find here in a version of 2015 that here HEPA element, the AFS 1992-17 says 99.97% due to military standards. So here we go to a more or less US standard, which I will show also in some slides. And the newest one at the end says again H13 is the minimum requirement, which makes it a little bit complicated because Europe is focusing on EN 6335 and Scandinavia will switch more and more to HEPA. And this is a little bit more complicated, especially if you want to have a back cleanable filter element, because normally HEPA is always glass, and as I said, we have the possibility to make a Ptfe material, but at the end it's really complicated. Okay, now, as I said, 99.97% is one value which comes from US. In 2016 or until 2018, we had a lot of processing in US because the OSHA said, okay, we have to do a lot of more for our people, especially in construction work, because the values they had before have been, I think, from the 70s. So here's the concentration of silicate dust was, I think, 125 grams per square meter before you have to protect yourself. And now they switched to 25 and said, okay, for different applications, you have to use always, or you have to use a kind of a filter, which has an efficiency of a minimum 99%, or for some applications, you have to use a HEPA filter. But this is an American HEPA filter, which is completely different to a European HEPA filter, because as I said, European HEPA means a minimum 99.95% efficiency at the MPPS, so normally let's say 0.15 micrometers, and for America it's 99.97 at 0.3 micrometers, so a little bit less than the requirements, but I will show you later they have different definitions of HEPA filter and also different definitions of which kind of efficiency is necessary and also which kind of particle size is necessary to get a HEPA. Always depending on the application you're working on. And let's say always we as the producer and also the producer of the vacuum cleaner has to take care that the correct standard is used, because it's an American market and they say, okay, you have to define which is the correct for the people they work with. Okay, just some slide about what in this case means for the OSHA 99.97 at a monodispersed particle size, so really just 0.3 micrometer particles, and then you have to reach the efficiency 99.97. There are two different standards, and definition is always the same at the end. But what they do, or what they did, is to define in which application you have to use which kind of vacuum cleaner or which kind of efficiency for the filter element is needed. For example, if you have a power saw, you cut wood or whatever, then you have to use the filter with an efficiency of 99% or greater, which can, of course, be done because it's no particle size defined, so all particles which are available have to be filtered at 99%, so it's possible with a cellulose material, let's say, at the end. But if you go, for example, to drilling, if you just want to drill, let's say, then 99% is okay, but if you want to clean the drilling holes, which is mostly necessary, then you have to use a vacuum filter with a HEPA filter. So a vacuum cleaner with 99.97% filter inside. More or less the same is here. If you have a grinder, then it's also necessary to have 99% or greater, and they added that the vacuum cleaner has to be a cyclone as a pre-filter, or it's necessary to have a filter cleaning mechanism for this kind of application, because you have a really, really high amount of dust, and so it should not be necessary to clean the filter element every 5 minutes or whatever. And due to this, they said, okay, you need a pre-filter or cyclone to protect the filter element, or the filter element has to be cleanable. Which comes to more or less a little bit of a side information, because if you want to clean a filter element, it's always necessary to use at first the complete filter area, which means if you have such kind of filter element, you always have leaf, and you want to use the complete filter element for the complete area which is inside, and not just half of the area. And due to this, it's always necessary to have a kind of stabilization which prevents that the leaf gets hollow, so stick together, and it's not possible to clean it back anymore. Which is possible, let's say, for example, for a round element with a band or a grid on the material or dimple. or a glue bead, corrugation in the material, or a mini pleat, which means also a lot of glue beads inside the material, which is more or less common for glass fiber materials. But also possible is a kind of a knot inside the material, which means you have here a really more or less a stable deformation of the material to prevent that dust can go completely into the pleats, where we have defined that different shapes of knots are really good for different kinds of applications. For example, if you want to have a back cleanable element, a P knob is much better than this kind of S knob, which means here that the material is more or less deformed like an S, which is really interesting for this kind of use of back cleaning, or when it's necessary to have a back cleanable filter element. And as you have seen before, they are also focusing on wood applications. And if you are a producer of vacuum cleaners, everybody knows that it's the most complicated dust is wood, really wood, because you have fine particles from grinding and so on, and you have also big, long fiber particles. If you cut wood, and then you have to use a different kind of pleat geometry, where you have really a big space between the pleats, which is more or less a little bit common, especially for wood applications. At the end, I would like to go to the military standard, which I already told during the Swedish standard. Here you can see you have, again, an efficiency of 99.97% at 0.3 micrometers. But 0.3 micrometers in this case is the mean particle value, so not monodispersed particles. It's the mean value of a particle of, let's say, particles from 0.2 to 0.5 micrometers, and it's a mass median diameter, which means the real diameter in counts and particle diameter is not 0.3, it's more or less 0.2 in the region, depending due to the fact that we have a mass median diameter 0.3. So again, more or less the same value, but the 0.3 is not monodispersed, the mass median diameter for multidispersed aerosol. Next standard, also interesting, especially if you are not working in critical dust systems like EN63335, is the ASTM standard, which is especially for commercial vacuum cleaners. So, as I said, hotels, motels, office buildings, whatever. Then you have to fulfill this standard in America, but again, a different definition of what efficiency is needed for the vacuum cleaner. Let's say, okay, 99.97%, okay, perfect, but not 0.3 micrometer monodispersed or mass median diameter. It has to be 0.3 in the particle range, has to be 99.9% in the particle range 0.3 to 0.5 micrometers. So again, different value. But at the end, they said, okay, you have to test it according to this standard, and this standard is then focusing on the European standard and second American standard, which is the ES standard, where they said, okay, yeah, you have to use a filter element with a minimum HEPA efficiency, but they doesn't define is it an European HEPA or an ESD HEPA, or is it a military standard HEPA? And then the complete efficiency of the complete meshing has to be 99.97%. So complete meshing again, like for the H class. So from my point of view, a really high requirement just for hotel cleaning, let's say. Or the other option is, again, the complete test against this standard. And to keep it a little bit more complicated, the ES standard, has 11 levels of filter performance, 6 different grades of construction, so different grades with fire resistant, fire retardant, and so on, with and without this kind. You have different tester aerosols, And here again, it's more or less orientating as a military standard for, let's say, the simple HEPA filter, and then to another standard, but at the end it's always the 0.3 micrometer mass median diameter, which means the count mean size, as I said, in the region of 0.2 micrometers. And what is really interesting is, for the military standard, you always have a HEPA filter, just a HEPA filter with type A, B, C. Nobody knows which means A, B, C, and it's not necessary to say which kind of filter specification you have done. But you see here, you have different efficiency which are needed, and sometimes you have to do a leakage test, sometimes not. And then at these standards, there's a big list of applications. If you go into hospitals, you have to use a B class, but if you have different kind of use in hospital, also D is possible, and so on and so on. And this is always a little bit more complicated. The only positive thing, say for us as a producer of filter elements, that it's not defined how often you have to test a filter element. It's not a 100% test necessary, it's just frequently to be tested. Let's say we do this at the moment, we test every production lot, 2 filter elements, beginning and end, to be sure that we will always fulfill the requirements. But at the end, frequently is completely free. You can also do it 1 time a year and say, okay, I have a filter element. Okay, as I said, just as a short other point for Australia, they use the same value like US, and they really orientate at the OSHA regulation, which means from our side and also from China, I didn't show all this Chinese standard, that if you have a filter element or vacuum cleaner, which is in the European standard and American standard, or let's say, from my point of view, the highest standard is always EN 1822, because it's 99.95 at Mbps. And if you have this kind of filter element, you can go completely all over the world and will always have the best filtration efficiency and always the highest class which is possible. And this would be, in this case, my last slide, because if I will go to the next, I think, 50 slides, then the day will be over. So thank you very much for your attention, and I'm open for your questions.